4.1, number 8. Let's try a more challenging problem than the examples that we had earlier. So it says, you and a friend are riding your bikes to a place that you think it's eastward. I'm not going to write all of the words for the problem. This is too much to write here. It's not worth it. So you are heading eastward at 16 miles per hour. Okay? And friend is heading northward from the same point. Both start out in the same place. It's important for the problem. Both left the same place, but friend is headed northwards at 12 miles per hour. Okay? Specifically, after you travel 4 miles, at what rate is the distance between you changing? Between you and friend changing. All right. Well, let's see. All right. First of all, let me draw the distance between you and friend. So it should always be something like this. All right. There's the distance between you and friend. Okay. This is important to note here. Distance between you and friend is not from here and then upwards, right? It's not that distance. It is the straight line distance between your two locations that you have at that moment. Okay? So it's always some sort of hypotenuse in these problems. Okay? So once you have a hypotenuse and you have a right angle here, some sort of right triangle geometry or right triangle formulae may come into play. Okay? It's very common in these problems, right triangles or similar triangles is another common theme in these types of problems to watch out for. When you're not given the formula in advance, the formula might have something to do with Pythagorean theorem or proportionality of triangles. All right, so right now, if I were to say that my position here, right, they said u, is x, right, from here, if we just called this x, right, that distance, whatever that is, and friend we'll call y, maybe, something like that. So there's x and there's y, okay? The distance, right? X is distance that you, I'm just going to keep using you have traveled from the starting point. And y over here is the distance friend has traveled. In the northward direction from starting point. Okay, so there we have a couple of variables to work with now. So if x is this distance and y is this distance, I might as well call this one z, right? The distance between you and friend. So we'll define z down here. Z, right? The red line, z is the distance between you and friend. All right, given that we have that, it seems pretty clear that x squared plus y squared has to equal z squared according to the Pythagorean theorem. Right? It's not the only relationship necessarily, but it's an extremely important one and used widely in these problems. Now, what are we actually trying to find though? Right, we're trying to find how z is changing, right? If z is this distance, they said, what is the rate of change, right, of the distance between you and friend? right when you travel, right when you have traveled 4 miles. So I'm supposed to find dz dt. Okay? How fast, again fast, is that rate changing? Right when what? Right when you have traveled 4 miles. This is a little trickier. You have traveled 4 miles means what? Well, if I'm going 16 miles per hour, I keep saying you and I, but you know what I mean. If you are traveling 16 miles per hour, the problem is one that made this personal, not me, right? If you were traveling 16 miles per hour, and then you check your stopwatch 4 miles later, how much time has elapsed? I hope you agree it's a quarter of an hour, right? So right when t equals 1/4, right? Now another way of saying that is what? i.e. x equals 4, right? There's two ways of referring to this moment. It's a moment in position for x, right? You have traveled 4 miles, so x is 4. It's also a moment in time, and that is if you're traveling 16 miles per hour and you've now traveled 4 miles, you've only gone for a quarter of an hour. Okay, so both these could be important and decisive in determining certain parts of dz dt once we have it calculated. So just keep that in mind. You need to think about how the condition on x could be also conditioned on time and how that might impact other parts of the problem.